Hello and welcome to episode 1 of C++ Weekly. I'm your host Jason Turner. Once a week we'll pick some topic of interest in C++ and dig into it with some live coding. In this episode, we're going to refactor the initialization of the ChyScript parser object. This code has bothered me for several years because it relies on some dynamic initialization of things that really are static, and the compiler should be able to better optimize things for us. So we'll jump right in the ChyScript parser.hpp file. We have this ChyScript parser, which has m multi-line comment begin, m multi-line comment end, m single line comment, m alphabet, m operator matches, and m operators. These are all static things that are exactly the same for all instances of the ChyScript parser, and they are constant. But because they are relatively complex to initialize, we have not been able to make them constant, and we've had the problem of having to initialize them with each time this ChyScript parser object is created. And there is a ChyScript parser object created anytime eval is called, or any time that you have an in-string evaluation. So let's look at these real quick. M multi-line comment begin and M multi-line comment end. They are both used just in the context of their C-string raw string pointers passed to this symbol underscore function. And this is true for M single line comment. So if we take these from being std strings and instead make them const char star constants, the compiler is able to simply replace these values throughout the code base where it makes sense. So we get kind of the convenience of a macro almost, and all of the performance that would come with something like that. This makes it more obvious what these values are, helps us to clean up our initializer list, and eliminates a function call. This should result in code that performs better at runtime also, because the compiler has more information at compile time to know exactly what it's passing to the symbol function here, and it might be able to do better inlining of the code. So we've got that working, and we'll kick off a build in the background just to make sure it's doing what we expect. Now let's look at our M alphabet operator matches and operators. We have this function called setOpOperators that builds our sets of operators, possible operator matching orders, and the alphabets of characters that might be allowed in any particular symbol type. Clearly, these are all things that the compiler should be able to have better knowledge of. So, starting with M operators, let's organize this code so that it's a little bit more, well, it was kind of laid out logically so that you could see what the different types of operators were: ternary, condition, logical OR. Note that I'm now separating these out. So bitwise exclusive OR, and then we had the caret. But it's time for these to live in a new place. Now ultimately, I would like to see these live as constant expressions also, but because ChyScript is a header-only library, we don't have a place to put the static instance of the const expression. So we see what really we just have is a few 11 actual calls to emplace back on this moperators vector. Now let's see what we can do with this. We have the vector moperators, and let's create for ourselves a static function that creates our operators. It needs to return std array. We're going to move to an array so the compiler can better optimize it, and we have fewer things of data living on the stack, living on the heap, which also gives us some better performance and less indirection in that case. So it is an array of AST node type objects, and 11 of them. And then we will create a static const. We're going to return a const reference to this data. Static const. And actually telling the compiler here that we want these bits of data to be const, it can actually do much better optimization for us. So this is one reason why casting away const in an object that was declared as const in the first place is undefined behavior, because it's entirely possible that the compiler will actually choose to optimize away everything that has to do with std array in this new code that we're creating. So we have our operators and the 11 values that need to live here. See if I can make my Vim editing more efficient while I am being watched on this video. Now, something I do not fully understand, but I know when I was playing with this earlier to make sure that I was doing something that logically made sense, is that the compiler warns if we only use one set of parentheses here, saying suggest parentheses around, braces around the sub-objects. And I can honestly say I don't fully understand why. So if any of my listeners here have an idea, then give a shout out, let me know. So we're initializing our static const operators, and then we're going to return a reference to it. And now our moperators can become an array of 11. And we want to make this a const reference. Now, one option would be to actually call this create operators function every single time we need to access the operator's value instead of doing what I'm doing here. But interestingly, there's actually extra overhead in calling a static value in some cases, and I might run over that later in another video. So we have now eliminated the extra cost of initialization for moperators and multi-line comment begin, multi-line comment end, and single line comment. Non-static, right. Needed to make these static. kick that off in the background now again. So I expect that to compile. So we have some more interesting things here. The vector of operator matches and the alphabet strings may be a little bit trickier. I guess I forgot to save. So let's look at alphabet. This really looks like something that we should be able to do at compile time. It's very straightforward. It's a bunch of loops. It's something that maybe could be a const expression, perhaps a function that creates these and returns them. Let's see on our documentation for standard array. So it says the constructor for standard array is implicitly declared. I don't see a way of specifying that we want all the values to be default false. So let's see maybe if we can make this into a constant expression. Give it a shot. Another spelling mistake. That should be create operators. Make sure that builds, or at least make sure it gets further than it did on the last build. Unfortunately, it looks like you are seeing not all of my face, but you'd probably be watching the coding more anyhow. Okay, that looks like it's going to work. So we want, let's see if the compiler will even let us do this. We want a static const expression function that builds our alphabet. And we want it to return a bool of max alphabet. Unexpected unqualified ID. Let's see instead. We can use std array of std array of bool of max alphabet. We want the inner type first. Let's see what that does. uninitialized variable alphabet, and const expr function. We need to swap these two. All right, that looks like that's going to work. Okay. So let's get our alphabet initialization code, which is here. And put this into the build alphabet function. All right, so with any luck, we are, let's double check this logic. So the first index, the outer index, is the number of alphabets. And then the inner index is the length of alphabets. I believe that's going to be correct. So we initialize the alphabets and return them. And now we can do a similar thing to what we did with the create operators. Static const array reference create, and we want to have a static const array of our alphabets or booleans. And have that equal to the result of build alphabet. And now we can return our alphabet. All right. Then one last thing to do is actually update the alphabet object to be stood arrays. Alphabet equals create alphabet. All right, I believe that does what we want it to do. So our static initialization can recur with a const expression, and then we can return a const reference to the contained alphabet array of bools, and then we can initialize our const reference alphabet All right, our last build worked. Hopefully this one does too. Now we get also compile time checking, that we're not indexing past the end of our arrays. Ooh, looks like we did misplace our 2 indexes. So there and here and here. Unfortunately, I don't believe we can use auto for our member variables. Call to non-const expressing function, std array begin. Intriguing. That's line 70. All right, that would appear to be a bug in the standard library, or an not the best anyhow option here if begin is not const expression. So we're going to have to do a for loop. Let's see what our options are. Looks like it has its own fill the container with a specified value. So let's do for I less than alphabet size. I know size is const expression safe. And then for each alphabet, we want to do alphabet of I dot fill If begin isn't const expression, then fill probably isn't either. Well, yeah, that doesn't make any sense that it would be const expression because we're modifying the array. All right. So we're not going to be able to use a const expression function here, but it is static, and hopefully the compiler will still be able to work with us. So at the very least, even if this cannot be fully initialized at compile time, it can be initialized at it can be initialized only once at runtime. That should work. We don't need that value to be const expression. We just need it to be static, so it only occurs once. And we need to remember the order there. Simple typos. Okay, one step closer. Now the only thing that we have left is our operator matches right here. This one is interesting. This helps determine operator precedence at runtime during parsing to make sure that the operators are all parsed in the order they should be. And it's pretty straightforward, I would think. Now, we can't do const expression if we're going to have strings. We could make this all flat arrays of const char stars, maybe. Let's see how operator matches are actually being used in the code. So we loop over them, and then we get a vector of operators, and if any of the operators match certain strings, so it's handy that they're strings because we're doing an operator equals equals on them, and otherwise we have to string compare. That's a little bit ugly. So we're going to leave them as strings, and we're going to see what we need to see next. So let's see. We can't make it an array of an arrays because each one has its own size. So that won't work. We could make it an array of vectors. That seems like that might be getting a little silly. So let's see. We might just have to go down the same road we did with this non-const expression of creating our alphabet. Build operator matches. Then we'll make our static const so that we only initialize it once. And we will call, let's see, static const. Wait, can I do this? Static const auto operator matches equals build operator matches. Return operator matches. And then operator matches now equals create operator matches. If we can do that with the auto, that definitely cleans up some of these bits of code. All right, it looks like the compiler likes that. So let's do that in one more case then. If we can do const auto here, it gives us one less place to get the order of those wrong. Now it looks like we plausibly increased our compile time with these changes, but hopefully it gives us better runtime. But more to the point, we've managed to save code that just wasn't very nice. Now we know that things are const where they should be const, and we don't have any kind of multi-phase initialization, anything. I really don't like calling initializer functions inside of constructors. I want as much as possible to happen either in the initializer list for the constructor or in the class initializers like we've been doing in this example, but not by calling another function. So we don't need this function anymore. That's compiling. And hopefully in a minute we'll be able to prove that all of our unit tests still run. And as we can see, there's still many different things that we can approach with this code. But we do have this, the TriScript parser is already not copyable or copy assignable, which would have been a problem with these const references. But the compiler should be able to better optimize this now too. And one example I was playing with a minute ago is this particular case, which is the model that we've been following. Is that we have a static const array of integers, which in our case they're enumerations, and we assign the local member variable a const array reference, and then we call this do thing. So we've got several levels of indirection here. Theoretically, when we call do thing, it would need to call obj9, and that would then need to look at the reference for this value that was created from this OBGS function, which is a static value, returns that. But the compiler is smart enough to tell us that this entire value is just equal to 0, and it returns 0. We can demonstrate that it does do the right thing if we change the value to there we go. So if we ask it for the value at the 1 index, we see that as val2, looking at this code. And we see that val2 should be the value 1. So it's pretty impressive what the compiler can do when it's given all the information that it needs. And hopefully we'll be able to take advantage of that same changes, but regardless, I think the code is better and cleaner, and I'll be sticking with it. So, okay, so a quick update. I let the build finish, and I ran the unit test, and all the unit tests passed. And the new code is on a release build with GCC 5. We are looking at 3 meg 753K for the standard library after, and the before is 3 meg 757K. So we got a slightly smaller build of the standard library. The TriScript executable is 1 meg 396K after, and the before version is 1 meg 404K. The After memory usage, it looks like it's almost exactly the same as the before. But we also look like we might have gotten a performance boost here. I'll need to do a little bit more checking to tell because it's kind of in the margin of error. But 7.1 seconds for our timing test versus 7.5 seconds. Now, my timing tests are being thrown off by the fact that we're recording this video, and I left the OBS Studio software running. But that's possibly some performance improvement while we were at it. So thanks again for joining.